Hi, Tatu. Can you hear me? I can see your mic. I can see your mic is connected, but I can't hear you. Right. Can you read that, Tatu?
Yes, so 111.
111.
Yes.
Oh, when you get to ask questions.
Yes, ma'am. Hello, sir.
Right. Can you hear me now, Tatu?
Yes, sir.
Okay. I was just away. Bianca is also here. Welcome to the class, Bianca. There you are. We are not gonna, we don't have to do video, Bianca, but we can. Right. Okay. You have to have a periodic table with you and a calculator and obviously something to write. Do you all have that?
Let me just get mine, sir.
Just get your periodic table. You need it. Every time you have class, you have a calculator, writing stuff, and a periodic table. Bianca, do you have one? Mr. Ramil, can you hear me? We're going to play around with concentrations today. That's the last bit of the stoichiometry that you're writing exam on. Then I have to work out some extra lesson times for you, which I'll give through probably by the end of the week. Okay, Bianca, if you can hear me, but you can't talk, just send me a WhatsApp so I actually know that. Because I cannot hear you. Or plug your mic out and in again. Or just leave the meeting and re-enter the meeting. Right, let's get started. Are you
sir.
ready, Tatu?
Yes, sir. Sir.
Right, we're busy just stoichiometry. I don't see any questions yet, so I'm assuming you have no questions.
Okay, let me.
You must have questions ready for me. Let's do a little bit of concentration work, and then we do all the questions you've got on the work that you're currently busy with.
Yes, sir.
Okay, good. There's two formulas that we need if we want to work with concentration. One is N equals C times V. So N is mole. C is concentration, and that is in mole per cubic decimeter. And volume is in cubic decimeter. And this formula, you know, N is a mole, the amount of mole. And that's mass in gram, and that's molar mass in mole per gram. Or grams per mole, rather, sorry. Grams per mole. But that formula you know. Right. Also, what is important? Concentration has two different standard units you can use. Okay, in school you mostly use mole per cubic decimeters, but that's the same as moles per liter. Why? The unit for cubic decimeter is exactly the same as liter. These two units are exactly the same. And cubic centimeter is exactly the same as milliliter. So take notes if you have to. We'll do one example of a basic calculation of concentration, and then we'll do 2 or 3 more harder examples, and then we'll do the questions you've got on the work you're busy with. Make your notes. Okay, Bianca, you need to sort out that mic, eh? You need to be able to speak. You don't have earphones, cell phone earphones or something that you can also plug in. The mic should work. Most earphones have got a little mic on the side. It should work. Try that. Good. Can I go ahead?
Yes, sir.
Right. So let's just do this example. I've got a small example here we can actually dig into, just to illustrate what we're doing. Okay, let me just move this little to the bottom. Okay, I'm going to take 5 grams of sodium hydroxide, and I'm going to throw that into water. So I've got a flask here. It's called a conical flask or Erlenmeyer flask, and that's contains 120 milliliters of water. I want to know, one, what is the concentration of the solution? Or you can ask, what is the concentration of the sodium hydroxide in the solution? Right, good. Let's just look at the equation. The amount of mole equals the concentration times the volume. So the concentration is the amount of moles divided by the volume. Well, the volume is cool, it's easy. It must be in cubic decimeter or liter. So I'm just going to take the 120 and divide it with 1,000 to make it liter. Same unit. But now I still need to calculate the amount of mole. I have an equation to calculate mole. Mole is mass over molar mass. So if I've got the mass, I can use that mass to calculate the amount of moles. And that is 5 gram over sodium, I think it's 23, plus 1 oxygen and a hydrogen. We put that in the calculator. Right. I don't know where my calculator is. So put that in Tatu, and then you see what you get.
Yes, sir.
I get a nice rounded value of 0.125. mole.
Yes, sir.
Okay, whatever you get here, you're just going to put that value in on top there. So basically in your calculator, you're going to write answer divided by 120 divided by 1,000. So it's going to be fraction answer on top. So it includes all the decimals. You're not allowed to round off here because it's not you're not answering the question. You're only allowed to round off at the end. And then I get a concentration of 1,004 moles per cubic decimeter. Right. You can screenshot that or write it down if you want to. That
Yes,
is
sir.
simple or basic concentration calculation. And then you can tell me when you finish, Bianca. You can just put up your hand if you're finished. Somewhere there's a little blue hand that you can put up. I don't know exactly where it is on a computer. I think it's somewhere at more or chat or something like that. There's an option you can raise your hand. Please try and find that. And Tatu, you're going to tell me when you are finished.
Yes, sir. I am done.
Okay, great. Let's do another calculation. Right, so I'm going to draw a drawing to explain the sum. So I've got a flask here. Conical flask. Inside that flask, I have 150 milliliters of water for H2O. And I'm going to put in that flask 3,5 grams of hydrogen chloride acid. Okay, so it's right. So the first thing I want to know, I want you to calculate the concentration. What is the concentration of my solution? Calculate the concentration of the hydrochloric acid. So once it goes in, becomes ions, it becomes hydrochloric acid or acid. I'll show you later when we do acids and bases what this equation looks like. You don't have to know it now. I just want you to calculate the concentration of the hydrochloric acid in that solution. And then we're going to do a next step. So we're going to add something to this. I want you also to do it, Bianca, even though we can't hear you. You can send me a screenshot of your answer. And Tatu going to give me the answer.
Yes, sir. Okay, let the equation guide you. The equation is mole is concentration times volume. So concentration is the amount of moles divided by the volume. So in other words, this equation is telling me I need the mole and I divide it by the volume. The volume I've got, it's 150 milliliters, but I need to convert it to liters or cubic decimeters. So that's 150 divided by 1,000. And the amount of mole I can only find by using this equation. Mole is mass over molar mass. The mass is 3,5 and the molar mass of HCl is 1 hydrogen plus 35,5, which is chlorine. I get an answer there. So I'm dividing 3,5 on top of my fraction over 1 plus 35.5. And that gives me, whoa.
39. Oh, it is 39, sir. I got the answer 39 for my mole.
39.
Yes, sir.
No. H2. Sorry, man. Not 1. It's 2 there. If I divide 3.5, remember, do the fraction sign in your calculator. Use,
Oh, yes, sir. It's 0,09 or 0,1.
yeah. That's, but you can't round off.
Round off.
So
Yes,
it's
sir.
0,09333 whatever mole. Is that correct?
Yes, sir.
So write at least 5 decimals. But when you do this calculation, you are not going to rewrite that on top of that. You're just going to press answer. Is that correct?
Yes, sir.
So when I do that, I go and do another fraction on my calculator. I put answer on top. So fraction, answer on top. And then at the bottom, I do 150 divided by 1,000. Then I get 0,6222.
Yes, sir.
So that's 0,62 mole per cubic decimeter. Good.
Yes.
Right. So because this is a question, I must end it off with a 2 decimal answer. Now I'm allowed to use that 2 decimal answer in the next sum. Right. This is the next sum. I'm going to take some of that out. I have another flask here. Another Alamar flask. I've got another one here. And I'm just going to take of that liquid or that solution. I'm going to take 72 milliliters of that solution. And I'm going to throw it in this flask. But this flask already has 50 milliliters of water in it. So I'm going to take 72 milliliters of that solution with that concentrate and throw it into another flask. Let's make this one B and this one A. And then I want to know at number 2, what is the concentration of the hydrogen chloride in B? Take a minute to think about what you're going to do.
Sir.
Yes, I'm listening. I have a mistake here. We have a mistake here. We have a small mistake. Just want to rectify it quickly. That 2 there, I don't know how it got there. It's 1 plus 35. I don't know why I put 2 in there. I did have 1 there and I changed it to 2 when I typed it in. Just want to recalculate that. Just want to fix this answer quickly, okay?
Yes, sir.
Sorry about that. That is 0,09589 whatever mole. And then I'm going to put that answer in there. And I just want to change this. It's going to be slightly different. So it's answer divided by 0,15. We have a decimal problem there. That's 0,64 mole per cubic decimeter. I don't know why I added 2. I wrote a 2 there. It's hydrogen chloride, and that's only 1H. I don't know why I wrote 2 there. Okay, cool. I'm listening to you. Tatu, what's your plan with number 2?
Sir, since the concentration of the whole solution, the previous one, it's 0,64, right?
Yes.
Um,
Just wait a
then I
second.
think
Bianca, you got what? Just look at that again, Bianca. Just type, sorry, Tatu. Just type 0,09589 over 150 divided by 1,000 in your calculator, and you should get that answer. Okay, Tatu, let's work. What do you want to do? Give me your idea or method.
Since like the since the concentration of the previous solution was
Yes.
0, like 64, right?
Mhm.
I think since we're trying to find the concentrate, we're trying to find the concentration or in B.
Yeah.
But sir, we don't know how much grams is HCI in the second
Yeah.
flask.
Okay, but I can do the following. Look at this. I can say, look, the amount of mole in the big flask A was 0,09589. Was that correct?
Yes, sir.
That's the amount of mole in A, the mole in A. But I'm only, what, dumping 72 out of the 150 milliliters in the next flask.
Yes,
You
sir.
see? So now I can actually work out how many moles is following that blue path. I can work out how many mole I have here. I'm throwing out 72 out of the 150. That's why it's important to actually write this amount of mole down here, because then I know exactly how many moles I'm starting with. So it would have been easy if I was throwing out 75 milliliters. Do you agree? Because that was half
Yes,
of the
sir.
volume then. And then I would have thrown out half of the molecules. But now I'm only throwing out 72 out of the 150. So let's do that.
The answer is like 0,46027392726.
So I'm taking out 0,04602.7. That's enough decimal mole. That is there in the 72 moles. So
Yes,
now I
sir.
can answer the question, because in B, the concentration will also be the amount of mole divided by the volume. And there's only water in it. So
Yes,
the
sir.
mole I'm adding are these 0,046027. And I'm dividing it with the total volume. Look, there's already 50 moles in it, and I'm adding another 72 moles.
It's 122.
Yeah, 122 divided by 1,000. So I'm just going to, for the sake of taking notes, I'm just going to do this. I'm going to write 72 plus 50 divided by 1,000. Because then you can
It
exactly
is.
see where I got those values. So I'm going to do answer again, divided by 122.
It is 0,377.
So the concentration is 0,38 mole
Yeah.
per cubic decimeter. Do we get that?
Yes, sir.
Just check this answer again.
Yes, I did it on my calculator.
Yeah, it's correct. Very good. Okay, I'm just going to look at Bianca. Okay, you round it up. You're not allowed to round off before you get the final answer. Okay.
Yes, sir.
Good. Next one. Okay, let's check here. Same type of thing. I have a flask. And in this flask, there's 250 milliliters of water. I'm going to add 4 grams of nitric acid. Right. Everyone, number one, what is the concentration of the nitric acid in solution? Big. Go. I can help you if you don't have a periodic table. Hydrogen is 1 gram per mole. Nitrogen is 14 gram per mole. And oxygen is 16.
Okay. So,
Yes.
so the oxygen, do I say like the thing? The molar mass, do I multiply it by 3?
Yes. There's
Okay,
three.
so
There's 3 of them. Equations.
uh,
Concentration is mole divided by volume. I'm not going to do the sum. I'm just going to show you the equations you need. Those two.
so the concentration is 0.25 moles per decimeter.
That's correct. Did you get that, Bianca? You can chat on this. You can also chat here. You don't have to WhatsApp. Whatever is easiest for you. Because I can't always follow the WhatsApps now. Okay, good. Let's start. I need the concentration. I need the mole. I divided by the volume. The volume is easy. It's 250 divided by 1,000, or you can just use 0.25. I need the amount of mole. The mole is the mass divided by molar mass. I have 1 hydrogen plus a nitrogen plus 3 times 16. Okay, let me get that value quickly.
Gets you 0.06349.
Very good. The mole is 0.06349 mole. I'm just going to use answer divided by 0.25. And then I get 0.25. Very good.
Yes, sir.
So that answer goes there. You're not allowed to do this arrow thing in exam, eh? You must write the value on top. I'm just showing you what we're doing. 0.25 moles per cubic decimeters. Good. That's the first part of the sum done. Now, I'm going to do something. I'm just going to change. I'm going to exactly the same what we did previously. I'm just going to change one thing. There's another flask, B. In that flask, right, let's change the color of the nitric acid. Make it green. In this other flask, I also have nitric acid in it. Okay, I have 60 milliliters. I'm trying to get this stupid thing out of the way. I have 60 milliliters of nitric acid, HNO3, and it's got a concentration of 0.1 mole per cubic decimeter. So this is B. There's another flask, also with nitric acid in it, but it's much less volume. It's only 60 milliliters, and it's got a lower concentration. Remember that concentration is in the top flask. So the flask B has 60 milliliters of nitric acid in it, and it's got a concentration of 0.1 moles per cubic decimeters. I'm going to take some of A and throw it into B. In fact, I'm going to take 112 milliliters and put it in there. Now I want to know, what will the concentration be in BB? B in B. What concentration of nitric acid will I have in flask B? Let the equation guide you. Concentration is mole divided by volume. See if you can find that. It's going to be almost the same as the previous example. Try and find how many moles we're throwing in.
Um,
Okay, can we find out how many moles we're putting in? How many moles do we have in flask A?
we have 0.06349.
So of the 0.06349 moles, we are throwing in 112 out of 100, 250. Is that correct?
Yes, sir.
Let's do that.
The answer is 0.02844.
Okay, so that at least we know how many moles is going in towards the B flask, right? Okay.
Yes, sir.
Now this is my equation. This one, yeah. I need to get those values right. Okay. So let's just start with the concentration. I don't know how many moles I'm putting in, but I know the volume in B. The volume in B is going to consist of 112 milliliters I'm adding plus the 60 milliliters that's already in the flask. And then I'm going to divide with 1,000 to get liters or cubic decimeters. So I'm adding 0.02844 moles from A, plus I already have some mole
180.
nitric acid in B. That's my next step. I'm going to find out how many moles of nitric acid I have in B. The mole is the concentration times the volume. And the concentration is 0.1 and the volume is 60 divided by 1,000. Now this is just 60 divided by 10,000. So it's 0.006, I think. Type that, 0.1, 60 divided by 1,000. 6 times 10 to the power of minus 3. It's the same as that, mole. So what did I do? I found out how many mole I'm throwing into B from A. I found out how many mole is already in B. And I'm adding these two. And then I'm also adding the volume. That I can do on the calculator. Just going to type it in like that. That gives me 0.2.
Yes, sir.
The concentration is 0.2 mole per cubic decimeters. Excellent. One more. Or do you have questions that we need to look at?
And let me just see in this textbook, sir.
Okay, Bianca, you can send me questions if you have any. Of the work you're busy with at the moment.
Mama? Okay. Okay.
Done. Okay, I'm giving you a problem that you have to work out on your own. There's a flask. In that flask, we are adding 4 grams of magnesium sulfate. Right? Okay.
Sir.
We want a concentration. We want to get or achieve a concentration of 0.285 mole per cubic decimeter. That's the concentration that we are longing for, or that we try and get. Right. First one. What is the volume of water that must be in the LMI flask? So what's the volume of water that should be in there if we get a concentration of 0.285? Calculate the volume of water in that flask. First step, both of you do that.
So volume is equal.
So mole equals concentration times volume. Volume equals moles divided by concentration. I have the concentration already. Bang.
Yes,
I
sir.
need to find out how many moles is 4 grams of magnesium sulfate.
Which is M. I mean,
What's magnesium?
magnesium is like 24 if
Is 24. And
yes,
sulfur
sir.
is 32. And oxygen is 16. So now I can work out the amount of mole. Come on your own.
Yes, sir. Mhm. Okay. Sir,
Okay.
I think the volume is 4, 5.
Right, you first need to get the amount of mole, which is the mass divided by the molar mass.
Yes, sir.
4 over magnesium plus a sulfur plus 16 times 4. Let's see what we have there. Oh, 0.03333, etc. mole. So the volume is that answer, 0.3333, etc. You can just press answer, and the concentration is 0.285. So what's that? The volume is 0.12 cubic decimeters if I round off to 2 decimals.
Yes, sir.
Okay, now, what happens now, number 2? Someone mistakenly adds what? Let's say 185 milliliters of water to the solution. So someone came past and just added the amount of 185 milliliters of water to that solution. How many grams of magnesium sulfate do I have to add to get the 0.285 mole per cubic decimeter concentration again? So someone added water unnecessarily. Now you need to add another batch of magnesium sulfate just to get the concentration back to 0.285. Calculate that on your own. Start with the equation always.
Okay.
You can't be done.
Sir,
Yes.
I think the answer is going to be, or let me just put this in my calculator.
I have no idea. I still have to work it out.
2,375
2.75 grams. Okay, let's see. Right, let's get the equation again. The mole is the concentration times the volume.
Yes, sir.
Okay, so if I add 185 milliliter, there's various ways of doing it. If I add 185 milliliters, then, okay, let's get the concentration first. I want 0.285, and the volume then will be what? I've added 185 milliliters, and also there was what in it already?
0.12, right?
0.12. So that was, let's work in the same values then. 185 milliliters is 0.185 cubic decimeters, and there was already 0.12 cubic decimeters in that. So this is decimeter 3 and decimeter 3. So that's the total volume that's in that flask now. There was 0.12 and someone added 0.185.
Yes,
So
sir.
let's just check that. How many moles do we have there? That's the amount of mole that should be in the flask if we want that concentration. So I need 0.086925 mole. That's what I need. But I only have this amount of mole in the flask already. Remember?
Yes, sir.
So the mole I need to add equals, that's which I need, that answer my calculator, minus that what I have in the flask already. So that's minus 0, 0, and then a lot of 3's. So I need to add 0,05359 mole. And I can actually work out how many grams that is. The mole is the mass over the molar mass. So the mass equals the amount of mole, 0,05359. And the molar mass of magnesium sulfate is, magnesium is 24 plus sulfur plus 16 times 4. So that I'm just going to multiply with 24 plus 32 plus 16 times 4 in a bracket. I get 6,43 grams. What method did you use? There's another way of doing it. That kind of sounds right, eh? Let me just think.
So aren't you supposed to like divide since like
No, just wait. Amount of mole. This is the amount of mole I need to add. You agree with that? So I worked out the amount of mole that we need to get that concentration. Then I took what I need and minus what I have, and this is the amount of mole that I need to add, and then I worked out the mass I need to add. There's other ways of doing it. You can ask what is the same at the beginning, at the end, and the end. It must be the concentration. But this is more logic. What did you do, Tatu?
I don't even know.
Pardon?
Okay, you see, after I got like the number of mold, right?
You got 0,0869.
Yes, sir.
Okay, you got that.
Then what I did from there was use the equation moles equals to amount of like grams divided by mass. But then I made a mistake. Instead of saying moles multiplied by.
Oh, you made a mistake, yeah. Also, did you work out the mole that you need to add?
No, sir.
Okay.
That's what I didn't do.
All right. Was there another way of doing it? I could have said, look, this is the mole that I need. So I need 0, I'm just going to make it slightly bigger. I need 0,086925 mole. So let's just work out what mass is that. That mass is 0,086925 times the molar mass of magnesium sulfate, 24 plus 32 plus 16 times 4. Let's do that. 0,08 6925, and then 24 plus 32 plus 16 times 4. That is 10,431 grams. That's a gram I need.
Sir.
So this is easier actually, root. This is the gram I need. But I have put in 4 grams. Right at the beginning, 4 grams.
Yes, sir.
So the difference is 10,431 minus 4, and that will give me 6,431 grams. And that's the same as that answer. That blue route feels easier actually. So instead of going the amount of moles I'm adding, working in moles, like we did here, I immediately go and say, okay, let's convert and quickly to grams because they want to know how many grams we want to add. So as soon as possible, go to gram. We went to gram. We found out we need 10 gram. Oh, we've got 4 gram in it already. So that's the difference. Okay, we've got 15 minutes. I'm answering questions that you've got. I want these lessons to change more and more towards questions that you've got because you are working. You've got every day you're doing science homework. Every day you're doing a bit of science. So there must be
Yes, sir.
questions that you've got. If you don't have enough science work to do, then you must let me know. I'll give you more. Also want you to start doing some papers that you find on the internet.
Yes, sir.
Do you have questions?
I'm trying to find the correct page on my thing. Then I'll send you the thing, the question.
You have no questions, Darko.
I do have, sir.
Okay, good.
Okay. Okay. Can I take a picture of it, sir?
Yeah, and send it to me.
Yes, sir. Um, 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 okay, just
You can also send me something if you have something, Bianca. If you can find something, or if you don't, you can look at what we're doing, or you don't have to.
yes, I sent you a thing.
Right, which one is that? Is that number 20?
Yes, sir.
This is a huge sum. Right. Green plants convert solar energy into chemical energy, blah, blah, blah. Okay, there's the equation. Carbon dioxide reacts with water. Okay, I don't know which state it's in. What is CH? Is that glucose? Yeah, C6H12O6 plus oxygen gas. To find the mole, okay, calculate the molar mass of CO2. That you can do. You agree?
Yes, sir.
Calculate the number of moles in 540 grams of that. So 20.3, the amount of moles is the mass over the molar mass. And that's 540 grams. And the molar mass of C6 is 6 times 12 plus 12 hydrogens plus 16 times 6. Answer. Did you do that one? That wasn't difficult.
Yes, sir. It wasn't.
Then you have 3 mole. Oh, that's nice. Good. Calculate the number of oxygen atoms. Okay, very good. 20.4. How many oxygen atoms are in 6 mole of 6 mole of C6? Okay, we have 6 moles of C6H12O6. So how many oxygen atoms? Okay, let's look at this. In 1 mole of glucose, if we have 1 mole of glucose, then we have 6 moles of carbon, 12
Yes.
moles of hydrogen, and 6 moles of oxygen. Very
Yes, sir.
Do you understand that?
Yes, sir.
So in 6 moles, I have what? 36 mole of oxygen. 6 times more. In 1 mole,
Sure.
there's 6. In 2 moles, there's 12. In 6 moles, there's 36 mole. Calculate the number of oxygen atom. Okay, I have the amount of mole now. So now the mole is the number of particles divided by Avogadro's constant. So the number of particles is the mole, which is 36, times Avogadro's constant, which is 6,02 times 10 to the power of 23. And that is 2,17 times 10 to the power of 25 atoms. Okay, good. Just gonna move this away. 20.5. Calculate the volume that we occupied by 6 moles of oxygen gas. 6 moles oxygen gas at STP. Okay, the mole is the volume divided by Vm. And at STP, my Vm value is 22,4. So the volume is the amount of mole. 6 times 22,4. Okay, what's that? 134,4 cubic decimeters.
Yes, sir.
Just check, oxygen is diatomic, but if there's only 6 moles, there aren't only 6 moles. Calculate percentage carbon. We have C6H12O6. I want to know, what is the percentage of carbon? All you need to do is take the molar mass of that whole thing. So you take the molar mass of carbon and divide it by the molar mass of the whole molecule. Let's just rewrite it neatly. Big M is molar mass. The molar mass of carbon divided by the molar mass of the molecule times 100 to get percentage. Good. So the molar mass of carbon, okay, there's 6 of them. So 6 times 12 divided by the whole thing, which is 6 times 12 plus another 12 hydrogens plus 16 times 6. And I multiply that with 100 to get percentage. %. Okay, cool. Take a photo of that, Tatu.
Yes, sir.
Are you happy?
Yes, I am.
There's something important here. You must get those mole ratios right. If they give you 3 mole of water, then you must realize there's 3 mole of oxygen and 6 moles of hydrogen. And then you can work out the particles, the amount of particles,
sir.
like atoms or ions or whatever they want to know. I'll see you next week, or I'll see you Friday, I'm not sure.
Yes, sir.
Is it Thursday or Friday?
It's Thursday.
Okay, it's tomorrow.
Bye. Yes, sir.
Remember to have questions tomorrow.
Yes, sir.
Good. Keep well. Bye-bye, Bianx.
Yeah, keep. Bye, sir.